Hello everyone, we are Team Emergency Turtles, and today we want to introduce the concepts and simple implementation of autonomous search robots for disaster sites using robotics operating system. So the basic concept is to implement the search robot. First, we hypothesized that we have maps or floor plan of the building beforehand, so we can set a suitable path for efficient exploration. And secondly, we decided that we should equip the robot with adequate number of sensors such as LiDAR, IMU, or camera to collect data from the site and navigate through a challenging environment without problems. And last but not least, we are going to need a platform that ties all the operation from getting a sensory data to giving out commands to robots, and by using ROS, we will be able to communicate with the robot on a Wi-Fi connection. The hardware we used to create our own search robot is called Turtlebot, precisely called a burger, which already comes equipped with LiDAR and IMU embedded systems so that it can do SLAM and autonomous navigation. In terms of modification, because we are making our own search robot, we thought heat detection would be very important, so we added the thermal image sensor for heat and camera for optical awareness. So let's move on to software side of things. SLAM, in layman's terms, means robots are always trying to guess where they are, and robots always keep the track of how much they turn and move to calculate what is called odometry. And by constantly cross-referencing other sensors like LiDAR in this case, they can much more accurately estimate where they are and also map the surroundings. And this is a poor example of SLAM mapping, and things like this happen when robots cannot take their own rotation into account. And things like this is utterly useless because it cannot really use in navigation. So let's move on to navigation. The first procedure of navigation is pose estimate, and the reason why they are doing this is because they are using two types of map, which is called global and local. And as you can see, the particles around the robot model is converging into one place. And that means the two maps coordinates are starting to get together. If the pose estimate is finished, then it goes on to path planning part. In order to make the robot reach the goal without hitting the wall, they use two kinds of planners. The first one is global planner, which sets the most efficient and fast way to the goal. And the second one is local planner, which is more like a controller for the linear and the angular speed to move without hitting a wall. And because navigation is not really omnipotent, you should always tune the parameters to get the best out of navigation. For example, if you set the inflection radius too high, then even though there's quite a bit of space between the boxes, the robot goes into the recovery behavior. When it comes to thermal imaging, because our sensor was 8 by 8 thermal sensor, it meant there were total 64 values in the array. So we was able to publish very easily into our REST server. Because it has such a small number of pixels, displaying the value right away will just show the blocky mess. And also because the temperature difference in ambient situation is very low, we set the minimum and maximum value of temp we are going to receive and upsampled into 240 by 240 to see the difference in temperatures. In terms of camera image, we have to take our Wi-Fi bandwidth into account because the size of camera image array is a lot bigger than other topics. So we compress the image and publish it, and we show the video of reduced resolution. Then we made a script which subscribes camera and thermal data and saves the image only when at least one of pixel sensor is larger than 36 degree. And this is the image of cup full of hot water during the demo. Then for demonstration, we'll build a very simple maze with boxes and we located 2 cups of hot water in different places. And then we set the robot's path in zigzagging from the north to cover all the places. If you look at the demonstration video, you can see the robots are navigating through the maze quite well, and because of the network bottleneck, you can see the camera's movement are a lot delayed. And because we set the bottom temperature as our ambient temperature, you can see there's no difference in thermal cam until the robot sees the hot water. See the demonstration result. You can see the first and second hot objects pictures were taken very nicely as intended. In the future, I would like to use cameras for actually measuring the object in front of you using camera calibration, and also we would like to use object recognition for a better performance at searching. I always thought saving others' lives is a noble job, but after knowing that firefighters are 2 times more likely to get cancer than normal people really broke my heart. So I really hope the development in technology will save not only more people, but their own saviors too. Thank you for listening to our presentation, and goodbye.